this is Introduction to Elasticsearch. It is an introduction to Elasticsearch. So if you want expert advice on tuning and scaling, talk to me afterwards. Or you can ask a question and hope I answer it in front of everyone. But I do talk a little bit about scaling it out. Most of the talk is concepts, how search works, how Elasticsearch works, and so on. So who am I? My name is Roy Russo. I am currently VP of Engineering at Predicto. It's a local, just funded startup that deals with predictive analytics and I guess big data, just to use two buzzwords together. I'm also a co-author on Elasticsearch in Action, which right now is in MEEP, which is Manning Early Access Program, or something like that. I believe it's out in April. There's a lot of back and forth if you've ever published a book with editors, so April can turn into August, for all I know. I still maintain a side project, which is ElasticHQ, and that is a free and open source monitoring and management platform for Elasticsearch. No software to install. It's all browser-based. You can actually run it right off of the HQ website. Prior to Predicto, some of the places I haunted. Silverpop, when I first arrived here in Atlanta, before it was actually named Silverpop. JBoss, when it was 5 guys in a room in Buckhead. And then Altisource Labs, which is still sort of around. All right. Why am I here? I personally know the guys that put the show on. So, all right. So, even though the concept of the talk is, or the topic of the talk is Elasticsearch, I figured I'd shuffle this presentation around a little bit. I've probably delivered this presentation close to a dozen times, and no 2 times have used the same slide deck. For some reason, I go and I start refactoring, just making one little change, and I end up with a completely different slide deck. I tend to do that with code too, which is probably why I went into management. I'm going to start with what is search. It sounds simple enough, but there's some nuances there that I can get into. What is Elasticsearch? So I'll dive into some of the overview of Elasticsearch and some real-world use cases. In essence, I've only put 2 in the slide deck right now, but I think they're varied enough that they give you some taste for what it can be used for or what it's used for right now. Scaling out is covered at a very basic level, in that Elasticsearch is out of the box a distributed and highly available search engine. Interacting with Elasticsearch will cover the REST API. So how you interact with Elasticsearch is all RESTful. They have something called the CAT API, which you can interact, I guess. Their attempt was to make the RESTful interaction un-JSON-like in its response, more human readable. So I'll get into that a little bit. I'm not a big fan of the CAT API, but the DevOps guys love it. Okay, so this will start to dig into what search is. At a very basic level, search is about filtering information, determining relevance. Back in the day, this is a car I hope to own one day. But this is how people used to search for stuff, right? So I guess you'd call it real-time searching. I know back in the days with MySQL, Postgres, Oracle, you'd do full text searching like this and hope for the best and hammer the database with every request. So In truth, search engines actually don't use magic. They use something called an inverted index. Is anybody familiar with the concept of an inverted index? Okay. The one guy that always heckles my ElasticSearch meetings. Not magic. For you engineering types, I've just been exposed to the term FM. So I worked with a lot of predictive analytics guys, lots of PhDs, lots of mechanical and electrical engineers. And whenever I ask them about their algorithms, they say it's FM, and they throw their hands up in the air. Apparently it's an engineering term. I didn't know. The M stands for magic. The F, use your imagination. Okay, so the concept of an inverted index. First thing, you take some documents, and just for the remainder of the presentation, when I use the term document, don't think binary. A document could be anything. It could be a log line, much like you'd see at an Apache access log, right? It could be a JSON blob. It could be a whole chapter out of some Edgar Allan Poe novel. So it's simply text with some attributes, and I'll have some examples here. So first thing, an inverted index takes some documents, you tokenize them, and tokenizing, fairly well-known concept to developers, I think. The idea is that you split the document up into some logical number of terms, right? Elasticsearch uses the words token and terms interchangeably. So just keep that in mind as I walk through this, that they're synonymous. So tokenizing them, in a very simple case, think splitting by space, right? So tokenize, I find my unique tokens, and I map my tokens to documents. So a little picture here. I have 6 documents. Apparently my documents only have 3 words in them. Apple, oranges, peach, probably should have been singular. And the green bars simply are pointers to which documents those tokens or terms appear in. This is what an inverted index looks like, and it makes searching really, really fast. I can only speak to how inverted indexes work in the Lucene and Elasticsearch world. My understanding, if there's any search gurus here working for Google or something, my understanding is that there's different ways to implement this, but at the end of the day, you end up with this. So now, searching for ApplePeach, let's assume an OR search, is fairly trivial, right? So we know our little green slots are where ApplePeach is and what documents they refer to, right? So that's how we find stuff with Elasticsearch at the most rudimentary level. Okay. The other aspect to search, as I mentioned before, was relevance. And again, at a basic sense, let's assume relevance is scoring. So relevance is not a trivial concept. There's different ways, I think, to approach it, and this is actually just 3 of them. So relevance, what do we mean by relevance? It could be how many times these terms appear in the document. It could be how many times these terms appear relative to the number of total terms in the document, of other total terms in the document. Or the frequency of this term across my entire document set, right? So my entire index. Relevance in Elasticsearch can happen at either, I should say scoring, or determining relevance in Elasticsearch can happen at either search time, so at query time, or when you create the index. you can also do it then. There are 3, possibly more, relevance settings in Elasticsearch, and they mirror what was in the previous slide to some degree. First, so term frequency is what Elasticsearch comes with out of the box default, and it's simply just attaching a weight to how many times that term appears in the document. Inverse document frequency is how many times that term appears across all our documents. There is also field length norm that can be set as a setting, and I think it's an oddball. I've never had a use case for it, but the idea is that you are adding weight to a term based on its length. I'm sure there's a use case somewhere out there, or programmers just went wild. So what is Elasticsearch? Elasticsearch is a search and analytics engine. If I was giving this talk, which I was a year ago, I wouldn't have had the and, so there wouldn't have been an and analytics engine. Somewhere around their version 1.2, they're at 1.4.2 right now, I believe, and their 2.x is coming out soon enough. But it was very well known as just being a search engine, a very good, highly available, distributed document store search engine. As of 1.2, a year less ago, they added aggregation APIs, which allow you to do some advanced analytics. I say some because you could do the mean, the max, the min, things like that. Kind of the typical stuff you would see at a relational database system, right? Sums, counts, things like that. So you could do that across your entire database. You could do that across your entire many databases. You could do it for only certain documents in specific databases. So you could splice and dice data however you want now with the aggregation API. It's how they call the analytics engine. I know for our needs as a predictive analytics company, it doesn't suffice. It's kind of rudimentary for what we do. It doesn't support FM, I guess. Elasticsearch is considered a document store. Like I said before, I will compare it to some other databases that are out there. A document store, for those that are familiar with Mongo or Couch, they parallel Elasticsearch, right? You're storing JSON documents at the end of the day. Every field in that JSON document is indexed on insert. And I guess just so I can get the vernacular down, the term index, whenever you hear somebody talking about Elasticsearch, can either be a noun or a verb. So to index something is to actually insert it into the database, right? So the noun index is comparable to a database, so in Elasticsearch terms. I have a little table that explains the terminology a little better. Hopefully that'll clear it up. Let's see. So Elasticsearch, like I said before, out of the box is distributed, meaning it has high availability and failover built into it. I do get into that on my scale out stuff. Okay. What Elasticsearch is not. So it's not a key value store. If you've met the React guys, Basho, I think the name of the company is. That's a key value store. I'd be surprised if not a lot of you have been exposed to Redis to some degree. It's popular for backing session caches and memory caches and things like that, right? So it's not a column family store. Again, DataStax guys were outside. C-star is what the cool kids call Cassandra. So if you don't know what C-star is, that's what it is. And then HBase as well is considered a column family store. Graph database, frankly, the only one I know of is Neo4j. I'm sure there's a new one every week. that I don't hear of, because that seems to be the trend these days, right? Everybody has a new database. So in a nutshell, and this serves more as an outline to what will come in the future of this presentation here. Elasticsearch is based on Apache Lucene. So question I ask at every presentation. Who here has used Apache Lucene? Okay, I think you've all dated yourselves. So Apache Lucene was something that I was exposed to early in my career as a Java developer, because that's how we would do search as Java guys, right? You would embed Lucene and you would run it that way, and it'd be this single node thing that would do some magic search stuff for you. Apache Lucene is actually the engine that powers Elasticsearch. It is what does the inverted index. Elasticsearch is a layer above that. So as I said before, distributed, it's HA, so you have a master node, you have other nodes in the cluster that are electable masters. If the master goes down, one of the other master nodes is elected to be the current master. So, on the distributed side too, when we get into the scale out section, one of the nice things that Elasticsearch gives you is that redundancy where not only are the nodes distributed across your cluster, the indices themselves are distributed across your cluster. Indices are actually spliced into shards, if you're all familiar with the term shard. So a index, the noun, a database, is sharded. And each shard comprises a portion of data for that database. And that is somewhere in your cluster. You really don't have an idea of where. But the idea there is that they are self-replicating. So if one of the nodes goes down and you bring a random one up, or you bring 5 more nodes up, they will actually relocate and try to kind of pollinate themselves, spread themselves out, so there is no central point of failure. Document-oriented, like I said before, Elasticsearch's language is JSON. You can try cramming other stuff in there. I never have. I know there's plugins for Microsoft-y stuff, like Word docs and Excel, things like that. Not something I've done. I think you could probably put PDFs and other binaries in there. But I think from what I've seen, those are third-party plugins. You could pick them off of the community. It's considered to be schema-free, unlike traditional relational database systems. There is no hard structure that you are bound to inside of Elasticsearch. As mentioned before, all communication with Elasticsearch is via HTTP. And that communication language is always JSON, right? So JSON in, JSON out, and HTTP, when it boots up, it's port 9200 localhost. Near real-time search. So the Elasticsearch website will probably say real-time search. There's debate over that. I'm not employed by Elasticsearch, and I'm not their marketing guy, so I'll be honest and say it's actually near real-time search. So if you've been part of maybe some of the other talks here, so Cassandra, the Weather Channel guy, I don't know, some other than NoSQL talks that have been going on here, you would have likely heard of the concept of eventually consistent, right? So Elasticsearch is eventually consistent. So you insert, you index a document, it will be there when you search for it at some point in the future, hopefully within a second. Okay. So near real time. Vibrant ecosystem. So if you don't want to deploy an EC2 cluster with Elasticsearch on it, there are hosting options out there. So there's cloud-based vendors that will do your Elasticsearch hosting for you. There are a lot of monitoring apps out there, the one I built being one of them. There's slight differences between them, but really, there's only one Elasticsearch API, so there's no innovation there, really. Elasticsearch, the company, actually has its own. I'll get into that a little bit. Oh, sorry. Let's see. The client SDKs. To my knowledge, there's Python, PHP, JavaScript, Ruby, you name a language, there's an SDK for it, either supported by Elasticsearch, the company, or open source project. The Java one, the Java API, I should say, that Elasticsearch puts out is poorly documented, but it's actually very well executed once you figure it out. I don't cover it in this presentation, but I've used it extensively. The way the Java API actually works is that it becomes a node in the cluster itself. So you're actually part of the cluster when you bring up your app and you're using that API. Spring Data has Spring Data Elasticsearch. Last I looked at it, I would probably stay clear of it. It uses a different mode of communication with Elasticsearch. It uses something called the transport client, which internal to Elasticsearch, they're soon deprecating that client. So I don't know what the Spring guys are going to do. Probably just use a node client like everybody else. Okay, so where can I get Elasticsearch? Probably worth asking. Who's currently using Elasticsearch in production? One. Okay, so. Wow, all right. So it is an introduction course. That's good. So I can basically say anything up here. And all right. So are you guys, is anybody using it in a testing environment? Okay, all right. And the same guy that heckles me at everything. Okay. All right, so it's free and open source. I believe it's Apache license. To my surprise, the Elasticsearch website changed within the last, I don't know, week or so. I have no idea. They changed the name of their company. They changed their brand. They're not elasticsearch.com anymore. They're elastic.co. And they have this really obnoxious website where you have to wait for every page to load, and it's got some spinning balls. I don't know. But that's where you go. And I will say their documentation is extremely thorough for an open source company. I came from JBoss, and we, okay, you're already laughing. So I came from JBoss, and our documentation was an afterthought, right? The idea there was the code is self-documenting. So these guys actually do a great job, not only documenting, but there's a lot of reference material there too, blogs and such, and articles on how to scale and stuff like that too. If you are courageous, you go on GitHub, pull down their source, and try to build it yourself. I don't recommend that. Okay, so now the company's named Elastic. The project, I know this is a big thing for people looking to evaluate new technology, right? I know your boss is probably saying, is there a company behind this, or is this some newfangled open source basement project? So there is a company behind it. They offer training, they offer support. There is a meetup here in Atlanta. There's an Elasticsearch meetup. It's met a handful of times, I think, within the last year. They recently added a module that supports authentication and authorization on top of Elasticsearch. I haven't looked into it. I believe it's for pay. I don't believe it's part of the open source Elasticsearch package that you download. This is important because Elasticsearch essentially, once you bring it up, is open to the world, right? It's port 9200, anybody can hit it. So be careful when you go deploying it on Amazon in the cloud, it's open. Marvel is their monitoring tool. It is free to use in development. It is really slick, it is really nice, and it gives you a lot of information. I mean, it tells you per node, disk writes, reads, JVM, heap, garbage collections, everything. It really gives you OS and system level data really well. And it's, you can build custom dashboards. It's really pretty. But if you go to a production, you have to pay, I don't remember. We got it quoted at, I think 4 nodes is $5,000, I think, something like that per year to use Marvel. So, all right, how do I run it? You download it. You go to the binary directory and you run the executable, which is just called ElasticSearch. And you hit localhost 9200. And you should see something like this. So again, I communicate with Elasticsearch. It's all REST, and it's always JSON. So, not always, the CAT API. I'll just table that for now. So you should see something like this. 200, the name, so usually the name of the actual server that it's running on. Your cluster name should not be Elasticsearch or Russo unless you stole my laptop. And version you're running and other stuff. So, okay. If you haven't noticed by now, Elasticsearch requires Java. There's a little subline. I sometimes have to give these talks with a lot of Ruby guys and PHP guys that whine and cry when somebody mentions the word Java. So there it is. Not everything runs on Node. Okay. So, all right, 5 seconds are up. Okay. Okay, use cases. So I would say the heaviest use cases I've seen, I say the largest clusters not only by number of nodes, but number of documents. So we're talking 80, 100, 120 terabytes, 130 node clusters, right? So all deal with solving the same problem that people have. And Netflix is a very well-known user of Elasticsearch, a very heavy user of Elasticsearch, which says a lot, right? Netflix is very cutting edge, very leading edge, and always big on scaling faster, right? Bigger, bigger. But they have a lot of machines. They have a lot of distributed software. And that generates a lot of logs. So what you'll commonly see is something called the ELK stack. Is what people tend to deploy into production with Elasticsearch, and that is Logstash, Elasticsearch Kibana. That's more like LEC, but anyway. So very simple diagram. Your servers, your software code, could be Apache, could be RabbitMQ that's running, whatever. Spark cluster is generating logs, and those are by the second, by the millisecond, by the nanosecond, little lines with a timestamp in front of them. Those are typically taken by Logstash, which is that log with a mustache. Or I think Apache Flume will do the same thing. And that is in charge of piping it into your Elasticsearch cluster. And then Kibana, which is that little cabana, is a user interface that sits on top of Elasticsearch. Kibana was, I think they just put out version 4. It is really slick, really pretty, really nice, very usable, custom dashboards. Yes, it's the same thing as Marvel. So it's the same UI, it's the same developers. This one deals more with being able to search through your centralized logs. Marvel's more on the monitoring side. Yes, you can do search, but it's more about monitoring. So I would say this is probably their heaviest use case. If you see best practices, articles, and things like that, it's usually centralized log aggregation. At work, I'd say it's going to sound weird from an Elasticsearch guy, but I didn't want to go through the hassle of building my own Elasticsearch cluster to have my own centralized logging. It's not my core competency, so it's something I want to just outsource, right? So we use a company called Loggly. Loggly is centralized logging in the cloud, and they just do this for me. So they have Elasticsearch that backs that. So, and then they have alerting and notifications and kind of nice add-ons that I don't have to build, right? So, no presentation is any good without a shameless plug. So just to put this in context, so I run an engineering team at a predictive analytics company. So we just had a startup round. It was a nice Series A, about 4 mil. But the company does have to deal with a lot of data. I know people like to throw around the term big data, but this is insane data. This is sensor data on stuff that I didn't think had sensors on them until I started working there. You know, from the DOT having sensors all along the roadways, to everything inside of an airport having sensors, to little beacons that are tracking us as we walk around, to your own cars, where the Verizon telematics is collecting everything. How fast you go, how fast you turn, how hard you brake. And that'll probably manifest itself in some sort of insurance bill later on for you guys. So all that data, by the nanosecond, by the millisecond, is essentially streaming in or dumped into our platform. Again, lots of data. It comes from a variety of sources. Cars, we normally deal with industrials, so think oil wells, factories, assembly lines, things like that. Every pump, every motor in a factory, things like that. Every press, all that. So all that data is coming in. It has to go through an ETL process, has to get transformed. The FM happens. I don't talk to those guys. They sit in dark rooms and all have big PhDs. But essentially, the models get applied and the magic gets output, right? And that output is webhooks or visualization or SMS, email, whatever. So how we use Elasticsearch is a very simple slide, right? So we use Spark. The original prototype the company had was all based on a relational database system. So the ETL was happening using stored procedures, functions, star schema, and materialized views, which gets a little unwieldy, right? And I don't necessarily want a DBA always blocking my engineering work. So we moved towards using Spark for the ETLing. Elasticsearch was convenient. The data coming in is very log-like. It's somewhat structured in that it's a line, I guess. But that data finds its way into Elasticsearch. It could be pulled out of Elasticsearch, and it can be visualized. So it was convenient for us. Elasticsearch scales nicely. There's also an Elasticsearch RDD. So using it with Spark was extremely simple. Spark is, by the way, one of those open source projects that reminds me of JBoss, because I don't know if anybody's using that thing in production, because the documentation is horrendous, but it works for us. All right. Is anybody using Spark?
Are you talking about Apache Spark, right? Whether Capital is using heavily. Yesterday they had so they are using.
Well, yeah, Spark and Cassandra. That's Robbie Strickland. Yeah.
They are using heavily.
Yeah. Those. Is anybody else using Spark production? Okay. All right. I think the same guy back there. Widely used. So just so I always throw this slide up because I don't want to look like I'm selling snake oil. But some of the companies using Elasticsearch, I know some of the use cases. Like I said, Loggly uses it for logs, not only aggregating but searching. Their infrastructure is interesting. I don't know if they use Spark in front of it or Kafka. But they deal with an enormous amount of volume that comes through there. Netflix, like I said, logs. If you ever do a search on Stack Overflow, it's actually using Elasticsearch. GitHub, if you're doing a search, it's using Elasticsearch. And both of those case studies are actually on the Elasticsearch website, so you can see like how big the cluster is and all that stuff. Okay, so Apache Lucene, free and open source. Talked a little bit about it already. Started in 1999, so I dated myself already. Created by Doug Cutting. Doug Cutting, if you haven't heard of him, started Apache Lucene. He's now, I think, working at Cloudera, so he's kind of a visionary, well-known ex-Yahoo Hadoop big data guy. What's it do? So Elasticsearch, like I said, is a layer over Lucene. It is responsible for tokenizing. Elasticsearch also gives you location-based search, so you can do polygons and distance searches, right? Relevance scoring, talk a little bit about that. Filtering, I'll get into. Text search, which this would be useless without, right? And then date parsing. It actually does more than this, but slide's only so big. So Elasticsearch is a document store, comparable to Mongo and Couch, as I said earlier. What these guys have in common, to my knowledge, I'm not a Mongo or Couch expert, so you can yell at me later. So they all deal with JSON in, JSON out. Those documents are defined as collections of key value pairs, right? So there's nesting involved. And versioning. Elasticsearch actually does versioning out of the box as well, so you don't have to do any magic. What is a document? As I said earlier, it could be a log line, it could be anything. But it's always in JSON format, as far as we're concerned. In this case, the document is something that you'd pull from the Internet Movie Database, which I believe is open API as well. So I think you can actually go to the IMDb and pull whatever you want out of it. So, so dealing with the IMDb here, best movie ever created, Scarface. I'm from Miami, so I'm supposed to say that. So that's what a representation of the movie would look like inside of IMDb, right? That document that we started off with is modeled inside of Elasticsearch in this form. So once it's inserted into Elasticsearch, this is what it looks like. This is what it'll look like when you pull it back out. So the name of the index, the type. There are no schema, but there is a concept of type. I'll get into that. Elasticsearch gives it an ID for you. You can specify your own if you'd like. They actually recommend against that. Advanced topic. Elasticsearch does the versioning for you as well. You could specify version as well. There's more to versioning than just little numbers. Elasticsearch actually does optimistic concurrency control. So think, if you're not familiar with optimistic concurrency control, if two people check out the same document, and one person modifies it, and then another person comes along and modifies it, the other guy that's still holding on to the original document won't be able to push his in, right? This document is basically branched off already. See, the source field could actually be disabled inside of Elasticsearch. A lot of people do that. Elasticsearch will store the source of your document in that source field, but it will actually store it outside the source field as well. I don't know how much I touch on this. I think it's actually in the next slide. Yeah, okay. So two things are happening on this slide that are worth mentioning. I'll start with the first one, because it's probably the most important, and it's something that seems to always be overlooked by people using Elasticsearch. You don't have to store everything in Elasticsearch. As a matter of fact, not a lot of people that I've met use Elasticsearch as their primary data store. So Elasticsearch is really, really good at one thing, and that's finding stuff and scoring that stuff, right? So use it as such. That store flag, I am basically telling Elasticsearch, for country, I want you to store the value of every time I insert a movie, I want you to store the value. But I don't want you to index it. Index the verb, right? In other words, I want you to store USA, but not indexing means it's not going to be searchable. Genre, I'm not storing it, but I want it indexed. What the flexibility that gives me is that I am now able to search on fields without taking up disk space, cache space, right, for having all those documents there. Second point, which is the main point of the slide, Elasticsearch is considered to be schema-free. It has the concept of dynamic mapping in that when I insert a document, when I index a document in Elasticsearch, Elasticsearch will auto-type that document for me. So inserting a document, the first document ever, into a brand new index, Elasticsearch will go through and determine what's a string, what's an integer, what's a float, what's a date, what's a geolocation coordinate. It'll actually type it for me. I can override that, but it's very handy that it does that because it actually allows me to do, so it does handle types differently, right? As you would expect, right? So you could do range searching on ints. You could do polygon math on the geolocation stuff, right? So it's handy that it does that. One thing I will say is that for those of you that are putting Elasticsearch out there, aside from locking it down somehow, like maybe putting Nginx in front of it, turn off auto index creation. Out of the box, Elasticsearch will auto create indexes for you. It would be like having a MySQL cluster out there that anybody can come along and just create a new database on it and new tables and such. Depends how you run your development organization. You typically don't want this kind of cowboy openness, right? Elasticsearch, we'll talk a little bit about the distributed aspects. First, I cut into the terminology. So if it hasn't been figured out by now, index, again, is either a noun or a verb. In this case, index is a database. A type is like a MySQL table. Document, which we've been seeing, right, is a row. Column is a field. So think in JSON terms, right? The schema is a mapping in Elasticsearch's world. In MySQL terms, relational terms, an index in the Elasticsearch world, we index everything, right? Unless you tell it not to index that particular field. Relational databases have SQL. Elasticsearch has a query DSL, which I touch on a little bit. By definition, a cluster in Elasticsearch terms is one or more nodes with the same cluster name. That's actually how they find themselves with the default discovery pattern. It's by cluster name. A node is one Elasticsearch instance, so it's one Java process, one JVM. A shard, I didn't cover this earlier, but back to Apache Lucene, a shard is actually a Lucene instance. So when I have one node with, I don't know, 100 shards in it, I actually have 100 Lucene instances running inside it. Shards have replicas, which we'll get into here. There's no need for a load balancer in Elasticsearch. There are different node types, and one of those node types is called a client node. That actually is a, I guess, poor man's load balancer inside of an Elasticsearch cluster. I get into different node types in a little bit. Indices are sharded, as I mentioned before. For any given index, quote unquote, database, it will be split up into shards. There's always primary shards and replica shards for that index. Unless you don't have enough nodes, Elasticsearch will always try to put replica shards on different nodes, right? It's kind of silly to have all the replicas sitting on the same node as the primary, because if that node goes down, then you've lost all your data, right? So it tries to balance itself out. As I mentioned before, there's always a master node, and if it dies, another one will be elected for failover. When you create an index is when you specify the sharding behavior. So sharding behavior is actually defined by the index. In other words, different databases, different indices can have different number of primaries and replicas. So in this case, if I'm building an index called Twitter, number of shards 3, number of replicas 2. What that means is that I will have 3 primary shards, and there will be 2 replicas for every primary. And I think it sort of looks like this. Okay, so this is a really bad picture, but follow me on this. So it's a 4-node cluster. I have 2 indices on this 4-node cluster. One of them is named index A, the other one's index B. Okay, and one's defined as having 2 primaries and 1 replica. 3 primaries, 1 replica. Right. So the A1 and A2 in dark blue is considered to be the primary shards. So that's how the node has decided to distribute itself, right? I didn't have a hand in telling Elasticsearch where to put my data, in other words. So it's gone ahead and said, I want to put A1 here, A2 there. And by the way, the replicas, which there will be 1 replica for every primary, are on separate nodes, right? We don't want the replicas sitting with the primaries. So, discovery.
Quick question.
Yeah.
How fast do the replicas catch up with the
Depends how much data they have. So the data has to be, or on relocating, or do you mean when you write? So if I write to a primary, it is near instant that the data gets replicated.
It's written at the same time?
Yes. But there is a concept of relocating. So if a primary goes down, or if a replica goes down, you will see shards, if you're monitoring in real time, you'll see a new shard come up, assuming you bring another node up, right? You'll see a shard relocate, and all that data now has to migrate over, right?
What's the minimum number of nodes you need for high availability?
So by default, Elasticsearch comes with 5 and 1. So if you don't specify a setting on your index creation, it goes with 5 primaries and 1 replica. So 5 primaries and 1 replica means you'll have 10 shards in total. That's good for most use cases. The tricky part, which I think I'll get into here, is you can never change the number of primaries, ever. The number of replicas you can always up, which is probably why they make it 5 and 1, because you can always change the 1 later on and scale it up. So. Discovery, so multicast, that means I broadcast out and say, hi, I'm looking for cluster name foo, right? Oh, you're in cluster name foo, let me join you. Unfortunately, multicast leads to split brain, which is a known issue. So I know when I deploy Elasticsearch, I go unicast. In other words, you're binding to a specific IP as such. So I'm saying, this is where the nodes in my cluster are. This is where you can find them. Is anybody familiar with split brain? Okay. Split brain is if you have a cluster running and one of the nodes, for some reason, loses connectivity with that cluster, with all the other nodes. And it happens to be defined that it can elect itself master, and now it's separated out on its own. What Elasticsearch does on split brain is that node now says, oh, I can't find any other masters. I'm going to make myself a master. So now I have my cluster fragmented. That's split brain. So to avoid that, you go unicast and you basically tell it where I can find my nodes. Master node handles cluster-wide. Essentially, the cluster state is handled at the master node level. You have So this is a slide that actually talks through the 3 different kinds of nodes. You have the concept of a master, a data, client node. And they're set using these flags, node.data, node.master. The idea here is that I can have dedicated masters. I could say, I don't want any data on this specific node. I just want it to be a master. I can have client nodes, which are load balancers. So that presumably I would have no data on it, and it would not be electable as a master. But it is there. It is part of the query calls in Elasticsearch. It's a little beyond the talk here because it really deals with tuning and sizing and scaling out your cluster. And data nodes just means this node will have data on it, right? So some of this, I think, was answered a second ago. You have the concept of a primary and a replica. So first-time indexing happens on the primary, and like I said before, it gets copied out to the replicas. Every index has 1 to many primary shards, default 5. The number is not changeable once the index is created. You can never change the number of primary shards on an index. So be mindful of that. Replica shards, you can actually change the number later. If a primary fails, a replica is electable to be promoted to be a primary. But if it becomes a primary, now another replica must be spun up. So how does that happen? More magic. The way that Elasticsearch works and scales on its own it actually distributes itself across your network. Given the example above, I can have 2 nodes. I have an index with primary and primary, replica. And if I add a node to this cluster, so I just bring up another machine with Elasticsearch on it, Elasticsearch will actually move that shard over on its own. So you will see, if you're monitoring Elasticsearch real time, you'll see shards that are unassigned. You'll see them initializing. This is on startup. Then started, and then relocating is what you see there. If you see shards relocating, that means something's going on. Either a node is going down, something's unreachable, or you're adding hardware instances. Right? How much time do I have? Yeah.
About 20 minutes.
Does that count? Question and answer? Okay. All right, I'll breeze through this slide. So, allocation awareness. A little bit of an advanced topic, but when scaling your cluster, all I'm doing here is I'm saying I don't want my primary and my replica to be on, in this example, on the same rack. I guess in case that rack gets nuked, for instance. Things like this can get a little more advanced in that sometimes you can have multi-zone replication, right, across Amazon East, Amazon West, right? The nasty part here is that if Amazon West begins to go down, you don't want all of those shards relocating to Amazon East and overwhelming Amazon East. So you could actually, with some nice tuning, stop that from happening. Again, a little bit of an advanced topic when you get into tuning and growth. Cluster state. So the cluster state API is helpful. It tells you everything you ever wanted to know about your cluster at that moment. The cluster state API is actually maintained by the master node. So you will see everything. You will see every index. You will see every node. You will see, well, you've not pictured here. You will see every shard in every node. You will see every shard for every index. All of it will be here. Any templates I have will be there as well. Okay, talking to Elasticsearch, said before, it's all REST. Get, post, put, delete, if everybody's familiar with REST. JSON again. There is the cat API, which is not JSON. Cat API looks like this. So this looks like it was created by some sysadmin that didn't like to have to fire up his browser, I guess. So this is non-JSON. They have human readable output. was the idea behind the CAT API. I prefer JSON, but I guess sysadmins like that world. There is a number of APIs available. These are the main ones you'll use when interacting with Elasticsearch. So document, which you'll see soon, right? Get, all the CRUD operations, right? Searching and all that. Cluster state, you saw. How are my nodes doing? How are my shards doing? Indexing, which you saw a little bit of already, and then searching. Okay, creating a document. So I'm going to walk through the little CRUD operations here, and then I'll cut it off in about 4 minutes, and we can do Q&A. Okay. All right, create a document. So in this case, it's as simple as this, right? I'm specifying a post command, post method, the URL to my cluster. IMDb is the index. Movie is the type, right? And that's my data. And what I essentially get back as a response is down here, created that version. And there's the ID. Okay. Things to note. You may want to shut that off. Auto creation of index, as I said before. Elasticsearch auto generates the ID of the document. Elasticsearch auto versions the document as well. Get, the get request is handled by ID. So same thing, index, type, ID, it'll return the document. In this case, I've kept that source field on, so it returns the entire document as I initially put it in. Updating a document, more like an upsert. And yes, it supports partial updates. Not for you, no. So deleting a document, it's essentially a delete command, right? So standard REST semantics, right? There it is again, partial document updating. You could specify the version, you could specify the ID. You could get many documents at once by IDs. There's an exists API, which is like a count, or actually like if exists, if this document exists, true, false. Bulk API is performant on bulk inserts, better than doing one at a time, essentially. So you can actually change this behavior in Elasticsearch, but the default is actually outlined here. So when you issue a search request, it hits a node, the node broadcasts to every shard in the index. Each shard performs a query. Each shard returns metadata about the results. That node merges the results and scores them. Next thing the node does is request the actual documents. So it has to determine relevance, and then it says, I want these documents, and it goes out and refetches them. I know it sounds like a lot of back and forth, but it's the default, and it's really, really fast. Take my word for it. So, with the REST API, you can do URL-based searching. You can even do some pretty compound queries here, right? So give me a movie. I'm looking for a string, scar, or star, and some date range, right? The Elasticsearch guys, the Elasticsearch community, will always tell you to use the query DSL instead. It does have some pretty neat stuff. So that's what a range query looks like. That's what string searching looks like. Boolean queries, very handy. And actually very difficult to do in the relational world. Just the must, I think, is easy in the relational world, right? Equals, like. Must not equals, not like. The should is interesting. All that should is doing is that if this shirt is made out of cotton, it's going to give it a higher relevance. That's all it's doing. So, there are other functions available. So range queries, as you saw, wildcard, regular expressions, bounded box, and geolocation distance. Let's see. Okay. I'll finish with analyzers and tokens. So, yeah.
Can you do faceted search?
You can do faceted search. I don't cover it here. Yeah, sorry. Yeah, that in my past, whenever I bring up facets, people kind of fall asleep. So now I only see half the people falling asleep. So.
Along the same lines, is that a good use case for building using Elasticsearch filtering?
It is, yes. Yeah. We could talk after if you want. Yeah. I don't want to go down the rabbit hole yet.
How do you compare with Solar and Elasticsearch? Suppose if you have the option, now mostly people use Elasticsearch, but what is the difference and why people are going for Elasticsearch? To some extent, haven't done Solar.
Yeah, so.
Both are on Apache Lucene, right?
Yeah, I think there was a time that Elasticsearch had, in my perception, better documentation and a cleaner RESTful API. And I think that time gave it a little bit of a hockey stick. Now I would say both projects are probably very similar. Why one chooses the other? Yeah, I'm not a Solar expert, so I couldn't tell you how one is better. They may not be, right? What I get asked a lot is Mongo Elasticsearch, but I think the difference is more obvious there. But with Solar Elasticsearch, the difference not so obvious.
Sorry, this is my last question. I saw that when you were showing that how you guys are using in your company, that you are using Spark SQL and probably extracting data from the SDKs and pushing it to Elasticsearch.
Yeah.
Is this true that you are doing, that means that you are actually having SDKs as your primary source of the data, and whenever you need to do some analytics or something, you are actually pushing it to Elasticsearch so that you can do a better search? And is that right?
So HDFS is used as part of the process, but most of the time the primary source of data, so the rawest data in its rawest form, is actually on S3. S3, yeah. But S3 is difficult. S3 is easy to read using Spark. You can read from S3 nicely. Writing to S3 is a nightmare with Spark.
So you will not use Elasticsearch as a more of a long-term storage of the data, right? It is more of you have it near
Right. So
more of research data.
yeah, if I had to, and I will most likely, if I had to store the data in its raw form, I'd probably go with Cassandra. So Cassandra is optimized for writes, and it's because of the level of log data that's coming in, right? Sensor readings, right? And they're just little lines, right? There's not really a schema there yet, right? I would go with Cassandra fronting it. S3 is there. It's MVP, first iteration. My assumption is we'll move to Cassandra, and then you'll have the Cassandra RDD playing with Spark, and then maybe pushing to Elasticsearch.
So, is Spark pushing the data from Cassandra?
What's that?
Is Spark pulling the data from Cassandra?
Not yet, but you can. I think the Weather Channel guy may have gone over that. I don't know.
Actually, they say that Spark has a direct integration with Cassandra.
It's the RDD.
Easier to pull it up and create a RDD so they can directly. But that's what it is.
That's true. Cassandra supported, S3 is supported too. Really nicely with Spark, yeah. So one last thing I'll talk about, because if you want to get any mileage out of Elasticsearch past the Hello World app you're going to build, you need to understand analyzers and tokens. In this sense, what I'm saying is, on this slide, when I'm creating a specific index, I am able to define how my documents will be tokenized, essentially. And how, in other words, how am I splitting up all those fields, all that text, so given some user input, it's easier to fetch, it's easier to find. And actually, I end up with relevant results, right? So it's on the slide. Slide deck will be available, but basically here I'm saying that it's probably easier on my screen, for this field message, I'm saying it's a string, and when you index it, in other words, when it's inserted, I want you to apply a specific analyzer to it. So it's going to tokenize by substring, and it's going to lowercase it, and it's going to remove stop words, right? So the, a, whatever, what. I won't go into it in detail, but it's something that you guys need to check out if you can, again, get mileage out of it. Have about 8 minutes. Questions?
Is there support for synonyms as there is in Lucene directly?
There are. So I don't cover that. I don't cover synonyms, and I don't cover autocomplete. So synonyms is more of a auto suggest, I guess, is what most people use it. Like if you use it for user input.
Well, so if someone's searching for something that has a synonym that's indexed, we want to have hits on that.
So it will support synonyms, and it will support, there's a word for it, and I can't remember. They're like words, and they're not synonymous. So plurals. Yes, yeah. So much like Google does, really, right? Cloud, clouds, cloudy. Right? Stemming. Yeah, thank you. So yeah.
Pagination. Is there any support for pagination?
So handled here. When you do a search, you'll pass in the request a first and size field. So 0, 10, 10, 20, whatever.
So you talked about logging and then being able to search your log, index and search your logs. So if I wanted a particular stack trace, error stack trace in the logs to be considered as a one document, so that when do I search, only that piece of stack trace should appear in my search so that it's easier for me to pinpoint the different errors.
Right.
Right. So how it can be achieved basically?
So every log line in that scenario, every log line is a document. The message is your stack trace, so it's basically a blob, right? How you tokenize a stack trace gets tricky because, if I can remember, in the Java world, you end up with fully qualified path, right? So you end up with com dot sun dot, right? And so you have to tokenize now. You have to split on dots, and assuming you're going to be searching by the name of the class, right? The standard tokenizer is going to tokenize, I believe, the whole string. So if you search for com, you're going to get everything. If you look for user repository, you're not going to get anything because it's in the middle of a big, long FQN, right?
Another argument in this situation may be that you narrow it by other things like labels and all this stuff, and then, or maybe narrow it down by the time that when you are probably some exception happened and not, and then you do that.
So yeah, I mean, so using logly, I've had to do the same thing, right? And you look for some sort of time range, so you could start compressing it, but it really does come down to how you tokenize. I know I've stored, unfortunately, my code has exceptions every now and then, and so those stack traces that end up there, you have to tokenize based on dots, and then there's also the line. Also, it's like colon line, things like that. So yeah.
So you have to do all the hard work.
It doesn't do magic. Any other questions?
Does it reindex after every create, update, and delete?
Good question. So it does, but you can force it to. So if you are piping in gobs of data, you could force a refresh on the index because that data, to some degree, is sitting in a cache and not accessible on a search or a get until it's flushed to disk, right? Okay. So yeah, you can force that. That's an optimization trick, though.
Right.
Yeah.
Have you used the attachment plugin? The attachment plugin.
No. Oh, so that, yeah, that's actually available out there. No, I haven't. No.
Apache Solar, there's this data import handler. You can have a database that you're indexing tables from, or you define your own schema over in that world. And so you can re-index individual documents just by sending in a REST call. Is there something similar in this Elasticsearch world for fronting a database to an index?
Am I piping from a relational database to an? Is that what you're asking? So.
A document and some representation in the database.
So the.
Base panel tables, I would say one-to-one.
So the nasty part here is, so well, the community will tell you to use something called rivers. The Elasticsearch guys will tell you not to use rivers because they're deprecating rivers. So rivers, as a matter of fact, I think Carlos back there, Foley as well, they had to build their own river that actually tailed the Mongo binary log and took that data and would sync it into an index in Elasticsearch. You can either build your own or use a river that's available. There's no easy answer there. The work that I've done, a lot of it in Akka, I end up having to store it in MySQL, and another actor is at the same time storing it in Elasticsearch. Keeping those two in sync is a programmatic issue. Yeah, yeah. There is no magic bullet on that one, unfortunately. I think everybody has that challenge when they're dealing with this polyglot data store where we're ending up today as an industry, right? So.
Yeah, it's an interesting use case of Solar to be able to have that option.
Yeah.
That reverse, is that the one? Because I think I used a module that where you can specify your query and all the stuff, and what it does, it goes and extract that information and dumps it into the Elasticsearch.
Yeah.
I'm not sure whether it was river or.
It's a river. That sounds like a river, and they exist for Oracle, Postgres, MySQL, Mongo. They exist for everything, but for some reason or another, I've never used one. For some reason or another, they're discouraged. The only reason I've heard is that the Elasticsearch is looking to discontinue having river plugins available.
Oh.
Because they attach to a single node, that node dies, and you can't find it.
That's what it was. Yeah. Carlos, this is the first time you sit in on one of my presentations, and you're actually helpful. I want you to know that. No, but that's exactly right. So when you use a river, I don't know how the Solar world approaches it. When you use a river, it's a plugin and it's installed on one node. And the idea there is that if that node goes down, you've now lost the river. And I guess that's why the discouragement.
Should not it immediately start replicating that information also to other nodes?
So that's the reason we started going with Russo. It's still conceptual river, but the idea is that it runs someplace outside of the actual cluster, so you don't have a dependency on the node that's running. So when we solve the problem, so we have separate servers running on one dedicated cluster, so it's highly available. It's writing into Elasticsearch using the same API, rather than being moved from the cluster, which is where the problem is.
The reason we were thinking of is that we have some data which was in a previous solution landed up in RDMA, but we are trying to get rid of RDMA for that reason, and we are dumping the data in Elasticsearch.
Are you making Elasticsearch the primary data store?
Not something like some data which does not need to be really mission critical data, something it does not need to go to the RDMA, it is better to go to. Suppose if you have events generation, right?
Yeah.
You will store those events in the RDBMS and pay use license fee because day by day you're instead you want to upload it to.
So it's like the log lines, right? I don't want to pay storage for all that stuff.
Indexing all the
What am I doing? Oh, thank you.